Hello, everyone. Thank you so much for joining us today and gratitude for all your time. Time, I always believe, is the most precious thing you can give. So, yeah, thank you so much for being here and let's learn together. So, the topic for today is build your first machine learning model. I'm Saishruthi Swaminathan, and just a bit about myself for this is the first time I'm meeting you all. So just a bit about myself and happy to hear about you all once the session is over, happy to discuss on LinkedIn as well. So a bit about myself, I work as advisory data scientist in AI strategy and innovation team at IBM. I'm an advocate for trustworthy AI and I'm an open source developer. I've contributed to projects like TensorFlow, Model Data Asset Exchange, Trusted AI Toolkits from IBM, and I work in a lot of data science engagement and contribute to what's an offering. And I'm a member of Linux Foundation AI and Data Trusted AI Committee and chair of DataOps Committee. Uh, Above all this, I love connecting with people and sharing whatever I have learned, through this journey. So I have given over 75 talks in the past 2 years. I'm an instructor in Coursera as well. You can find my courses on data visualization, and I have
Saishruthi,
course.
sorry to interrupt. So I think your voice is low. So you just want them to raise your voice.
Can you hear me fine now?
Yep, I can.
Okay. Yeah.
Yes,
Thank
you can.
you.
Thank you.
So yeah, and I'm instructor in Coursera as well. You can find data visualization courses in both Python and R in Coursera. And with this, let's get started. Let's see what is in store for today. What are we going to see or learn today, right? So we are going to solve a client's business problem using data science methodology, but with a twist in the process. We are going to see a bit, a twist or a different way of the methodology, which is away from the usual methodology that we see online. Also, at the end, we can learn about how to present the findings to our stakeholders. Data science is all about storytelling. So let's learn how to present the findings to our stakeholders. The reason for having it as a story is I believe, story sticks to all our mind. So instead of going through a regular presentation format, I kind of created this entire presentation based on our client Dolores. So let me introduce you all. So this is our client for today. She is Dolores and she is the CEO of telecommunication company. And we are all data scientists now. Imagine that we are all data scientists, in a company X, and Dolores is our client, and she's approaching us with a business problem, and she's seeking for guidance. So that's the story, and that's the basics for today. So, what is the process that we are going to see, right? So we are going to start by having business discussion with our client. First, we learn what is the problem faced by her company, understand the impact it has created in terms of brand value and revenue. And after getting in depth information about the problem, know if this problem can be solved using data, right? So once we get the clarity, we need to really think, is machine learning approach actually needed, right? Not all problems needs to be solved using machine learning and deep learning technique. That just because it's interesting, it's new, we don't need to use machine learning or deep learning techniques for solving all the problem. So let's see how to justify ourselves why we need to use machine learning or deep learning for the platform. And as I've mentioned, this is the twist in the process. All the green color highlighted one that you're seeing are a bit different from the regular data science methodology. We are going to, analyze the requirement with the client and what are, expected deliverables from the process. And now our data science team along with the design and the ethics board members, are going to sit together and understand the unintended consequence of our system, right? Before building the machine learning model, I believe this is the first process. We all need to know, even before learning all the framework, all the deep learning, machine learning framework code, which we can learn at any time. It's important for us to understand the unintended consequence that our system is going to create in the society, right? So after that, we obtain our data, we understand, uh, we understand our data, we understand the glossary, make sure it is a good representative of the population for whom we are trying to solve. Next important aspect is handling a sensitive data. How do you handle sensitive data? How can you make sure that the data that you're handling uh, is by the accordance of all the rules and regulation imposed, right? And next, once it is done, we convert our business problem into data science question. We explore, we extract answers from data, and then we develop the model as usual, right? We develop the model, we use different frameworks available, and then we evaluate the model, and we check for fairness throughout the process. This is again a twist. I know this is a bit overwhelming for beginners. I'm not going in depth to all the fairness packages, but at least I want to convey that this is an important process in the methodology. We want to make sure at every step we measure for fairness. We want to make sure at every step we don't affect any certain communities, for or any certain group of people for whom we are designing the system, right? And finally, if everything is good, we will deploy the model in production and keep it ready for deployment. So this is the overall process. So this is, uh, like a methodology, but with a bit of twist in terms of adding the fairness check, in terms of adding the explainability check, and in terms of adding design thinking for checking the ethics of the application. So this is the process that I was talking before. And now let's get back to our story. So our CEO is facing $1 million dip in the revenue due to customer attrition. Customer attrition, by this I mean they are losing their customers. They don't know what to do. They keep losing their customers, but they really can't predict what is the issue, right? And they are looking for ways to tackle the issue. And the requirement by our client is, first they need to analyze the current, the churn data, the attrition data, and they want to look for patterns. They want to understand why it is happening. They want to understand what are the factors that is causing, this customer attrition problem. And the next, they want to develop a prediction system. They want to develop a system. Yeah, so on they want to develop a system which can predict future customer attrition. So yeah, so this is our core, requirement. We analyze the churn and we create a prediction system. As I have mentioned before, whenever you approach a problem, it's important that we need to justify why we are choosing the machine learning or deep learning approach. First one, not all the problem require the approach. So what is the justification in our case? So customer churn does not happen with specific set of factors that, okay, factor A, factor B, or factor C is the reason for losing my customers, right? It can be anything. The dimensionality can be anything, right? So the factors may overlap, or there may be too many reasons for the churn. And the second is a scalability. Let's say you just have 100 customers and it's easy. You can just take your Excel and do your analysis, for example. But what if you have millions of customers, right? What if you have 100 features and millions of customers? It's going to be too much for any sort of analysis or manual analysis. So with this justification, we decided to go with machine learning and deep learning approach, and we proceed getting our customer data and kick starting the process. So the next step, Dolores, the CEO of our company, the CEO of the telecommunication company, connects her database management system with our data engineers. So through this, we obtain the data set structure, glossary. Glossary is nothing but we understand what is there in the data. We will see all this in our demo in few minutes, but I want to complete the theory part before getting into the coding part. So, and then we provide the API access to, we get the API access to data, we get the extraction step, supporting document. So what our dataset contains? Our dataset contains information for about 6,000 users, their demographic characteristics. Demographic as mean, by this I mean from where they are from, what is the age, gender, and so on. The service they use, the duration of the the service, what is the method they are paying, and amount they are paying. Right. So now we are done with the data part. Let's just quickly see. So we are done with the business discussion, and then we know why we are solving using machine learning, and we got our data, right? So next step, I know you are all waiting for demo. I know you all want to directly jump into the coding. I really appreciate that. I really appreciate the enthusiasm. Most of the time people want to jump into demo, but let's hold on for 5 minutes, and I'm sure this 5 minutes will be worth listening. Ethical design workshop. Let's take a turn in our methodology and get into an ethical design of the solution. If you are going to, let's say you're trying to get into data science field, right? Or if you want to switch your career to data science, or if you are a data scientist itself, we have over 300 participants here, whichever stage you are in, right? uh, Please make sure that you add this ethical design component to your projects, to your daily work, and to your career path. This is important, this is crucial, because we are all responsible for each other, right? I'm not being philosophical here, but it's important to really go through this step before touching your notebook or framework. So what I'm going to talk here. So it is important to have a workshop to discuss about the values each of the party possess and think about unintended consequence of the application. So what we do is we obtain the value of our client company, and we have our own company values, and we start the design thinking process. So whatever you're seeing on the screen is called Mural snippet. Sorry, it's called Mural. Mural is a tool which we generally use for design thinking. If you're not familiar, please, like, you can just I will post the name on the chat. Let's make it a bit interactive. So let me post the name in the chat. It's Mural. So you can Google this and create an account for free, and start using it, right? It's not just for ethical design, you can use it for any sort of brainstorming for your project. So yeah, so whatever you're seeing on the right side of the screen is the Mural snippet. We start by writing our design goal, right? First, what do we do is we first write what is the problem we are trying to solve, and we understand who we are trying to solve and why are we trying to solve this problem, right? Why it is important. And the next column you can see the list of values, right? Privacy, equality, trust, fairness, transparency, explainability. So first, then we identify the 5 most, for example, human values for your target audience. As a group, your client and the company and your own company, we need to sit together and discuss the value that we are going to choose and why. So based on this, we kind of agree with a set of human values. As a group, we need to think about what your own company value is, right? And try to see if there is any match between the value. If there are any similar value between the list, it's awesome. If there is some contradicting value, if let's say you value more for fairness, whereas your client values more on the explainability of the model, right? Then you need to sit together and make sure you have an agreement. You know what are the values you are going to target. And also you need to write the hope and fear, like what do you hope that the application will solve, what do you fear that the application will bring in, right? So hope and fear of this hope and fear of this application. And next, here you can see layers of effect. So this is the layers of effect, the one that I'm highlighting. First is the primary. So what you do is you just sit together and create this three different poster. One is primary, secondary, and tertiary. And in primary, write down all the effects that comes to your mind when you think of your product. So primary effect is the heart of your product. They are always intended, they are always known. Right? For example, if you take help, what is their primary effect? Is to, it's a platform for people to review and learn about all the establishments, right? So write about the primary effect. Next is a secondary. So this might not pop up immediately because this is not the defining characteristics of the product, but it is still relevant. For example, let's take Twitter. The primary effect, as you all know, is a social media platform. What is the secondary effect? It can also act as ad revenue generator, right? So these are the effects that are not the core of the product, but they are relevant to the company shareholders. Finally, is the tertiary. The reason for highlighting this, having is a bigger sticky, is this is where you think about unintended consequence. It can be good or bad. They always surprise, right? Once you release the product, they always surprise you. For example, cyberbullying. We don't intentionally create an app to encourage cyberbullying or massive trolling, right? But it happens like this. So even before releasing the product, even before designing a product, let's think about the tertiary effect, what good and bad your application can bring. So make note of all the conversation. Now we are all set for application design and data analysis, because we are very clear after this step what is our primary goal, secondary goal, and what will be the good or bad effect of your application and how to resolve them. So this is the ethical design workshop. Uh, so this is the ethical design workshop, and let's get into the next step. Okay, we need to make sure we handle the data as per the data regulation, and all the personal identifiable information is protected. And double check, we use the data as per the condition specified when acquiring information from the customers. So we are done till the data production check. We are done till the ethical design. We know our data and we know our business problem and our intention. So let's directly jump into the notebook. I'm sure you're all excited for this. So let me post the notebook in chat. Are you all going to work along with me, or okay, I can just quickly go through the notebook. Here. Awesome. So once we are done with all the analysis, we directly get our data. So in this use case, I'm using Kaggle telecom users data. As just to reiterate, our goal is to see what are the factors affecting our customer attrition, and we're going to create a prediction system which is going to tell whether the particular customer is going to stay with us or not, right? So just in case if so this is the data set that I'm using. Let me post in the chat. Okay. So if you are using Google Colab for the first time, you can just type in Google Colab in your search. I'm sending you the search words, and you can click on. I mean, you need to have Gmail account, of course, and then you can click on the GitHub here and use the link that I posted there. You can add here, and then click on new notebook. And oops, sorry. So you can go. Yeah, and then you can click on this icon, so your notebook will open. So let's start. So first we need to install all the Python library that's needed. So I'm installing Plotly, which I'll be using for visualization. And now I'm importing all the libraries here. I need Pandas for my data analysis, NumPy again for data analysis, and Plotly, Seaborn, Matplotlib for data visualization. And for model building, I'm using the Scikit-Learn package. So I'm providing path to my data file. I hope you all can see my screen properly. Okay, so when you want to build your machine learning model for the first time, first we start with the data understanding and data analysis. So we read the data here, and then let's see let's see first few rows in our data, right? So we use df underscore data dot head. Head is the function from our pandas that we will use to see first few rows in the data set. So as you can see, so these are the rows and this is how our data will look like. And I have mentioned at the beginning of the session, it's important to have your data glossary in your hand when you're building your model, right? Building a machine learning model or getting into machine learning or deep learning field, it's not just about learning, let's say, scikit-learn, TensorFlow, and learning your, let's say, logistic regression, linear regression algorithm, right? It just doesn't start there. It starts with data. It's important that we need to have our data glossary. So these are the fields that we have in our data set. For example, class customer ID, and then I have explanation for each glossary item. For example, let's say monthly charge, right? So what does this monthly charge field means? So it's a current monthly payment. So I need to work with a domain expert and then get this glossary with me as I start working with the data. And next, I'm dropping the unwanted column. I'm using pandas drop function here and providing columns that I don't want for my analysis, because this is like like a noise in the data. As you can see from the I don't need customer ID for building my model, right? I'm not building for any specific customer, so this might not give us a good analysis result. So I'm dropping here. Okay, so next step, your machine learning model will not be able to handle all the missing values or the null values, right? It's going to learn all the garbage information that's provided. So we need to clean our data first. And a point I want to make here is data scientists spend 80% of their time in data cleaning and data visualization, and just 20% of their time in machine learning and deep learning. So whenever we hear machine learning and deep learning, we always think, okay, this is the hot topic, right? Uh, so we typically mentioned, this is the first. Oh, just a second. So, for example, we take this information, right? Like first we need to see if there is any missing value. If our data set has all the values intact, or if there is any value that's not there, right? From from the result here, that's why I told we need data glossary. So we typically use the monthly charge, we typically use the total charge. These are all amount. You can just see the name and understand they need to be in numeric field. They are numbers field, right? They are not uh, so they are usually numbers, and they are not some string field, like some they are not like sentence, or they're not words, right? They need to be numbers. But from the result that I can see, it looks like a number. Sorry, it looks like a string. The object data type is a string data type. If you're familiar with all the programming and stuff, float, int, they all indicate numbers, right? And we use the data info, and then we see, okay, the total charge should be numbers, whereas here it's not a number. So the next step is we convert it to number. So we use this value count to see if we have any string values there, if we have any values that are not numbers. Can you hear me? Am I audible? Uh, okay, sounds good, because I'm seeing some I'm monitoring chat on the side, so if I'm breaking up, I'm really sorry.
No, no,
Thank you.
you are actually audible. Yeah.
Thank you. So there are about like 10 blank values here. So we need to see how to fill these blank values. Okay, so the easiest step, if we have, let's say we have 6,000 rows and I have only two missing values, right? The easiest is to fill it with 0. Removing the rows is not a good option, because you're going to lose your 2 data points, or like 10 data points, whichever it is. So removing is not an option in most of the cases. So first we need to fill. We can either fill it with 0, or we can fill with mean, median of the feature. And sometimes, you know, we even use other algorithm, right? We even use algorithm like finding the nearest neighbor, or some other algorithm to uh, fill the missing values by itself. So here I'm using, because for the demo purpose, I'm going with the level 0, the first option, which is filling with zeros here. So yeah, so I have converted all my total charge, miss the values that are actually like spaces as zeros. And next is a business problem. The next step is converting the business problem to data science question. Now we have our pre-processed data. Let's generate some question, right? As you remember the first requirement from our client is, what are the factors causing the employee customer churn? By customer churn, I mean, what are the factors causing, our employees to go out of the organization, right? They're losing their customers. So what are the factors? So looking at the field, we can come up with as many questions we want, and we can try to answer this question using the data visualization. So some example question is how partner gender dependence are related to this churn. So, and are we losing customers who are staying for a short time or a long time? Is there any issue with the internet or phone service? And you know, and is there any issue with the streaming service? And is a monthly charge or the total charge causing the employees to run away, right? So these are some of the questions that I came up with. But if you go back and actually look at your data, you can also come up with quite a number of questions. So let's get started. Guess there is some. Let's just rerun. I'm restarting it. Looks like there is some issue with running this code. So I'm installing this again. So usually when you go for live demo, this is what happens. Your code runs till the last moment. Okay, so now we are done. Let's see what is happening here. Awesome. So yeah, what I'm going to do is, for each question, I'm going to create a visualization, right? So I'm using Plotly library here to create the visualization. So this one, group by, I'm using Pandas group by function. So group by is the most commonly used function for, for a data analysis. You typically, as the name suggests, you typically group all your features, provide gender, partner, dependence, turn. So here I'm going to group everything, and then I'm going to, provide the color, title, and I'm going to use Plotly tree map graph for this visualization. It's pretty clear, right? It's obvious. All the red ones are where our concentration needs to go. So uh, let's see, this tool looks, it looks like it occupies a lot of space. So we can just click on it, and it's going to expand and tell you whatever it is, right? So you can play with it. That's what it's a most interactive way of visualizing your data. So typically, try to use Plotly for my visualization. And the next question is, are we facing churn with customer with longer tenure, right? By longer tenure, I mean, if customers are staying with us for a long time, are they going, will they stay with us? Or for, let's say I have customers who is with me for like 4 or 5 months, right? Will I use customers who are staying only with 4 or 5 customers, or my company is going to lose customers who stay with me for years and years? So who am I losing here, right? So that's the meaning of this question. And here I'm using the histogram visualization, and again using the group by function to get this visualization. You can actually go back and you know uh, you can actually go back and review the GitHub link that I've posted. Let's see. And next is the internet service. Then I want to make sure the services that I'm providing, right? Phone, internet service, these are the services that I'm providing. So am I having issue with these services, right? And next, am I having issue with my tech support? Is my client company tech support is not good? So I'm using again histogram to see and group by function to get the visualization. And next is an obvious one. Let's say I'm making my customer pay huge amount of uh, you know charges, right? Huge amount of money for a service they are using. Is that causing a customer churn? So I'm going to test my monthly charge. Here I'm using Seaborn plot. It's a KD plot. uh, so here I'm using Seaborn plot to get my visualization. And finally I'm going to see if there is any streaming service problem, and if which type of payment customer prefer. Like, do they prefer 1 year lease, do they prefer 2 year lease, and month to month lease, right? And you can just click on the chart and it's going to expand. And the code is pretty simple, right? It's just 2 lines of code, not even 2 lines, I would say. It's just one function. And this particular chart is called sunburst chart, and this is the plotly one. The plotly sunburst, I'm using group by function, and I'm providing the path here. And next is the data pre-processing. Now that we are completed with the data visualization, we took our data, we cleaned our data, we visualized our data, and now we are entering into the data pre-processing phase. We are getting our data ready. We are getting our data ready for our model. First thumb rule is a model can understand only numbers. So let's say you are giving a string value. Let's say I'm giving apple, orange, right? It's not going to understand. I need to provide numbers for my model so that it can perform the computation. It can actually, understand what I'm talking about. So what I'm going to do is, if there is any string value, we need to encode it. Again, this is a rule. Whichever model you build, even if it's a text data or natural language processing model, there is a concept called embedding, where you will take your model, and then you take your data and convert it to a number. So how do you convert? I'm visually showing you how to do this. So we have this x, s, and no. And yes, we encode it to 0, and no, we put it as 1. So this is called label encoding. And next is one hot encoding, right? If this concepts are too much for you, I would I will send links later on that you can refer. But now you can visually understand what the encoding means. You can clearly see I'm moving the s to 0 and no to 1, and this is one hot encoding. So you convert yes to 1 and 0, and no to 0 and 1, right? So how you do one hot encoding is, you take the unique set of values in your response and create that many columns. Here I have 2 unique value, yes and no. So I'm creating 2 columns, one for yes and one for no. Whenever my response is yes, I put 1 under that, and I put 0 under all the other column. Whenever response is no, I put 0 under this and 1 under the rest of the columns. So this is the code for getting that. You can use, there are different library, there are different functions that can help you do your data encoding. Here I'm using Pandas get dummies function. So I need to provide my data. I need to provide the columns that I need to encode, right? So this is the Pandas get dummies function. And this is like tenure, monthly charge, churn, gender, female. So can you see here we have two unique gender, male and female, in this data set. So it's converted into columns, right? Gender female, gender male, and wherever the value is, it will put 0 and 1. So this is called one hot encoding. So now that we are done, we have also encoded a target column. We are assigning no to 0 and yes to 1. I'm just saving the transformation for deployment. We are not going to the deployment part today, but I have the step in the notebook if you want to try that as well. So final check I want to do is I want to see if my data is balanced or not. Can my by balance I mean let's say I have two target column, right? Yes and no. Am I having 50-50 split between yes or no? For example, if I have 100 data points, am I having 50 data points for yes and 50 data points to no, right? So looks like it's not balanced. It's not 50-50 split. So let's keep that in mind. Again, these are like more, this is like a medium level topic. So I'm not going over that, but I want to get you all exposed to this kind of scenario as well, right? Finally, we are in our algorithm phase. First, we clean our data. So without all these steps, just diving into your deep learning or machine learning algorithm is not going to work. It is going to backfire the entire process, entire learning. And even if you are in the phase of your job search, if you are a student, if you want to transition to data science career, it's important that we understand the process. It's important that we understand how to handle the data, right? How to design the solution in ethical way and how to handle data. And for handling the data, we saw data cleaning, data pre-processing stuff, encoding stuff, and visualizing stuff, right? So this takes 80% of the work, and next 20% is about building your machine learning model. So how do you choose? There are different frameworks, right? Scikit-Learn, TensorFlow, PyTorch are like top frameworks that are going to that has like functions for that has API for all the uh, all the models, all the algorithms that you can use. I just want to know if you're all familiar with uh, all these framework names. If not, I can add. Let me just take a pause and go there. So I'm going to add this in chat. So this is the Scikit-Learn framework. So this is the Scikit-Learn framework. So it's going to provide API for classification, for regression model, for clustering. Clustering is just grouping, right? Classification is, as the name says, you classify the image, for example, as a cat or a dog. Regression means if you are working with numbers, right? The amount, the running numbers, for example, predicting salary, right? It deals with numbers, so it deals with continuous value. So that's the regression type. And then you have, if you want to use any API for model selection, dimensionality reduction. Dimensionality reduction is, let's say you have million feature in your data set, like million features in your data set. How can you reduce your data set dimension? So this is the Scikit-Learn framework. And again, just for all your reference, this is a huge space, right? What I'm trying to give you all is an overview. What I'm trying to give you all is a high level perspective of how to build a model along with ethical design of the solution. So let's just have that in our mind so that we set our expectation right. And I feel it's important to go through the process. So this is the TensorFlow framework. Again, they also have this Python API. This is a bit complicated one, I would say. Scikit-Learn is the easiest to start with. If you are a beginner, if you are starting this for the first time, if you are starting to build machine learning model for the first time, then I would recommend going with the Scikit-Learn first. For some reason, I'm not able to send a message. Okay, so you can type as TensorFlow, as I'm showing here. This is another framework. But Scikit-Learn is the easiest if you are beginning, or if you are beginning your journey. You can, it's a pretty good, it has a pretty good user guide. It has a pretty good API documentation that you can refer. But I'm not going to overwhelm you all. I'm just getting back to the notebook here. So some tips, if you want to, you can ask me, right? There are hundreds of algorithms out there. How can I choose? First, I want to know if you all like to hear these tips. If not, I'll post that in the channel so that you can take a look at it. But on a high level, we want to make sure your model is explainable. Can your model say what is in there? Can your model explain why it is working in certain way, right? And how fast you want to train, or how fast you want to get your prediction, depending on your training speed, depending on your prediction speed, depending on your explainability of the model, and number of features it can handle, right? So some algorithm will not be able to handle a lot of features. Let's say neural network, let's say deep learning, you can handle a large number of examples and millions of features, but some of the machine learning algorithm will not be able to handle like millions of features, for example, right? So yeah, so depending on the number of features it can handle, depending on the memory, can you load your data fully, right? Whatever you're seeing online, like all the data sets are small, they don't represent the real world data. They're pretty small. So sometimes we need to make a decision based on the loading aspect, whether you can load the data fully or not, right? So these are some of the tips that you can take and think about which algorithm to choose. So for this, I'm using a classifier called AdaBoost classifier. This is one of the model. As if you go to Scikit-Learn, if you go to classification, you have list of models here. And that's why I mentioned before, there are a lot of models that you can try, but to pick and choose, you need to, you can use those tips that I have mentioned before to choose which one you want to go with, right? So what this particular classifier will do is, so every time it is training, I'm going to explain in a simple language. I hope this looks simple. Every time you train your model, it is going to take what are the incorrectly classified example, right? Let's say you have 100 data, and out of 100, 20 data points are incorrectly classified. So it's going to take those 20 data points and it's going to retrain again. And out of 20, let's say now your model predicts 10 correctly and 10 incorrectly. It's going to take your 10 incorrect example and it's going to train again, right? Till your model is able to predict your 100, not 100, like as much as possible, like it depends on the accuracy number, as much as possible it's going to keep training your classifier. If you are in this field for the first time, if you are building your first machine learning model through this session, how we do is, we need to separate the feature column with the target column, right? If you remember, if you are from the beginning of the session, you know, we will have what we need to predict is if a customer is going to stay or not. So if if a customer is going to stay with the company or not, right? So it's a yes or no target. So I'm splitting my feature and target separately. I'm dropping my target column in my process data, and I'm getting my feature column separately and target column separately. So the next step is always splitting your data set into test, validation, and train. For the purpose of demo, I have only test and train. The reason is you train on, as the name says, right? You train on these data points, and once you train, you take your train model and you test on your test data points. So we will use scikit-learn test train test split. Usually we go for 80-20 split if it is test or train. 80% will be training and 20% will be your test. I guess there is a question about the random state here. The reason for having random state is not your split will not be same all the time, right? For example, I have 100 data points. In my first try, my first 80 will go to train and next 20 will go to test. But when I rerun this code again, my first, let's say, only my first 50 and the last 30, right, will go to train, and in between all the data points will go to test. The split is not consistent every time, so you will get a result differently, every time you run your code. Your split will be different every time. So you need to make sure we set the random state so that we get the same result. It's for the repeatability purpose. And then we use the AdaBoost classifier, and I'm not using any of the parameters here, since it's like the basics of building. I want to focus only on the API and the framework and the process. So I'm just directly giving the AdaBoost classifier function here from scikit-learn. I am initializing the classifier. This is how you initialize, right? You just assign it to a variable. The first method, you use the fit method. Fit is where you fit your training data to the model, and the input will be your training features and the target features. Your training features here is X train, and the target features here is Y train, and then you fit the model. So once you fit the model, obviously you need to see how your model is working, right? So we go for metrics calculation. We need to test our model. So this is our trained model, CLS. This is where our trained model will be. Now we are going to predict on the test set. We are going to take our trained model and predict on test set. Just as I have mentioned before, I have split my data set into train and test. I have my test set here, X test and Y test. So I have my X test here. And then, I'm using, these are the classification metrics, accuracy. Accuracy is pretty obvious, right? How accurate your model is. The input I'm using the scikit-learn metrics accuracy score function. And the parameters that you will provide here is your target column and your model prediction result, right? I'm giving my test data and I'm asking my model to predict, and I'm measuring my accuracy score. So I have my accuracy, recall, precision, F1 score. Again, these are the classification metrics. If you go to scikit-learn, you can pretty much learn from all the resources out there, but you want to know more, you can just go to this link and then you can choose metrics. So these are the metrics that are available in scikit-learn. So these are the API based on your use case. I go with, I just went with accuracy because it's a basic one. It's obvious one if you are using the tool for the first time. But usually accuracy is not the best metrics for classification. But here we have accuracy, and then I'm saving the model for. So I'm saving the model for the purpose of my deployment, which I will not be covering today. So now I know that my model is like about 80% accurate, and these are the other metrics that I wanted to, demonstrate. So let me just take a pause here to see if you have any question. So there's a question here. Does the role data engineer need to have machine learning or deep learning knowledge? So data engineer usually deal with data processing. That's why I'm mentioning this right from the start. It's important that we know how to deal with data. I guess the role will come till SQL, database handling, and all your data pre-processing stuff, and it doesn't deal a lot with the machine learning or deep learning knowledge. So what will happen if you provide random state equal 10? So based on the number, it's going to split your data set accordingly, right? If you want to know more about how the split will change, I would recommend taking just the function from Scikit-Learn tool, Scikit-Learn framework, or the toolbox, and then try to provide the input, right? Try to get into the code and provide the input to see how it is splitting. So every time you provide different number, the split is going to be different. So next question. So what are the skills required to become a data scientist? So as I've mentioned, I have tried to cover pretty much the skills required. To be honest, in this presentation, it really starts with business understanding, and then getting your understanding your data, creating the problem statement, and then with respect to tools, of course, data cleaning, visualization, building your model, evaluating your model, right? And I have an excellent article. I'm not sure if I can get it now. If I can send those articles after the session, I'm happy to send those articles, which clearly tells what are the skills and which tool that you need to learn if you're stepping into the career.
Saishruthi, so thank you for the session. Before moving to the Q&A session, so I would like to launch a poll. Okay, so for the users to rate the webinar, and users we have a data science program which we provide live online classes weekdays as well as weekend batch we have with 100% placement job. So this is a complete paid program. So if you are interested, just fill the poll that I'm going to launch now. I've launched the poll. Please, everyone, answer to that. So, yes, Saishruthi, you can carry on with the Q&A.
Okay, so data analyst doesn't really need, machine learning or deep learning skills. They, hardly deal with the deep learning aspect of it. So I would suggest, if you are focusing on data analyst position, you can really just focus on those tools, right? Data analysis, data cleaning, data visualization, data processing tools, rather than machine learning or deep learning. So feature selection rejection procedure. So feature selection is a huge topic by itself. It really depends on your business domain, business use case. That's why I have mentioned you need to use the glossary first to understand which feature we need to include. But there are other ways, like PCA. There is this component analysis, which is going to give you the top features that are required for building your model in a good way. So there are algorithms that can help you do the feature selection, but the basic starts with the business domain analysis. So
Guys, please drop your doubts in the Q&A so that
so
Saishruthi
if
can
you're
answer it.
sure. So, if you are asking me for books, I typically go with Coursera. When I started, I did my courses on Coursera. I was a student, so I was able to I started, and I took all these online courses, right? I,
And even
I,
GUVI as a data science program.
yeah, that's what I was about to say. You are taking a poll here. So I want to generalize and say it's about, I joined an online, platform, learning platform, so that it's more interactive for me to learn. And it's all about practicing, right? Let's say I have given you some tips here. It's important that you take, you know, uh, you take the project uh, by yourself. Let's say you have some instructor in GUVI, you can, connect with them, get some data set recommendation, build your own project, create your own portfolio. So it's important that you have different projects to showcase when you are approaching for a job search. So yeah, I think it's a good question you are asking. Like, what did we actually infer from the machine learning algorithm, right? Uh, I I have this part. This is the data storytelling part where we really talk about the stories that we inferred. Uh, and I'm. Is it okay if I just share the presentation with the attendees so that they know what they will do after, you know, creating the analysis and
Yep,
machine learning algorithm?
definitely.
And then there's a good question. 80% accuracy is fine, or do I have to go on another model, right? So again, you got to sit with your business people to see if it's accurate for their application, right? That's why I didn't go to all the other metrics, because accuracy is always, it's not a great metric to get into a conclusion. Sometimes the application can be so complicated that even getting 80% is awesome, but sometimes 80% is not good. You need to, keep working on, keep training the model with different parameters, right? You might think why I always give the answer as connect with the business domain, but in reality, it is what it is. And accuracy is the basic metric, but this metric is not enough to get into a conclusion that your model is performing great. I have other metrics in my notebook, like precision, recall, and so on. So we are building a model, getting some result accuracy, what we can do using this. So that's a great question again. So let's say you build your model, right? So once you build your model, you save your model, and then you have to learn, you will pass on your save trained model to your DevOps team, ops team, like this development operations team. The DevOps team is going to deploy the model, right? Let's say your business people are fine, your stakeholders are fine with the model performance, and they want to use in their application. You take your model and pass it on to your DevOps team, who is then going to, use the Docker, Kubernetes, and all the other DevOps best practices to create a REST API for your model so that you can access in your application. So that's another world by itself. But you go back, talk to your stakeholders, present it, and they are going to come back, you know, uh, saying that okay, let's go for the deployment part, and you hand it over to the DevOps team. Before that, it's important that we evaluate and get stakeholders uh, take on it. Yes, confusion matrix can be used. That's an excellent metric as well, because it has both precision, recall, F1 score, along with accuracy. So that's a great metric as well. I have that in my notebook, but I didn't go through for the sake of simplicity. So each metric has its own meaning, right? We are just seeing the name accuracy, precision, recall, but each metric has its own meaning. So I guess, I mean, if possible in future, we can actually go one by one metric to understand what the metric is telling us, right? If we take just the accuracy, it's telling us I'm able to classify 80% of my data correctly. That's it. And it doesn't tell you that 80% is just for class 0 or just for class 1. That's an example. So that's why I mentioned that this accuracy metric is not a great way of measuring your model performance. Typically, you need to, go with other metrics. uh, if you are trying to get into the field, I would start again with the basics of handling data, analyzing data, whatever I have been through, like learn visualization. It's data again, data science. It's all about storytelling. So we go through all this. You really need to be comfortable with all the topics that I've mentioned before, and then we need to learn about how the algorithm works, right? If you actually want to become a data scientist, it's important to know math behind this algorithm and how it works and how to interpret the result. Okay, so what is the final prediction? So final prediction, I didn't predict for one data point, right? I predicted for, let's say, 20% of my data. So from 20%, I need to filter out, I need to see what my model prediction is, and then take action accordingly. That's where the storytelling will come into picture. So I have everything in my slide. So this is the deployment part, which I don't want to go over today. So once we, test your model, you can take your, that's why I saved the model. If you see the last cell in my code, I'm saving my model. And once I save my model, I can take it to my production. Can we have more than one target value? Of course, yes. So this is a simple classification problem where we have only one target value. There is a concept of multi-label classification where we can have more than one target values. So whatever we have seen is a pretty basic one. It's the step one or the process that we go through. So is it hard to work with all? I don't think it's hard to work with all the algorithm. It's all about understanding the math behind, right? I I started as electrical engineer and then I moved to data science. I know the pain and the learning curve that is going to be there for you all if you are trying a data scientist position. But it's not something hard. It takes practice. It takes regular, being with the community, learning together, and then doing different projects. So I don't believe in the fact that you need certain number of years of experience as a data scientist or some data job to become a scientist. Maybe that's why I always suggest people to show their uniqueness in terms of project, right? It's from my own experience. I'm not saying anything that's out of, or out of story or fantasy story here. I did not have experience in data science before becoming a data scientist. So I didn't. I wasn't a data. I was working as a software engineer before joining as a data scientist. But I worked on for 2 years, uh, rigorously doing different projects, attending classes, and staying with the community. Right. I learned together with the community. I go for all meetups. I go for online classes, and then I did a lot of projects. I was like in the top 10 in all the Kaggle competition driven data. So that's how it really depends on the route you take. uh, if you want to go with the traditional route, it's going to take some time with the resume, and if you want to be there with the community, do different projects, learn online, it's going to be pretty easy. It's not hard like it's not hard as it looks like from a person who doesn't have a data science background. I can definitely say that. So of course, yes, we need mathematics skill, because I personally prefer we need to understand the math behind the algorithm to crack it. What will you do when you deep? So it's just an interest, right? If you're taking data science just for the purpose of job, it's going to be hard. It's going to be boring. But imagine, just make it interesting, right? If it's something interesting, let's say we are spending hours and hours on social media, right? Because it's interesting, we can because it's exciting for you, because that's what you like. uh, the same thing applies here as well. I personally don't see this as a job. This is something that this is a part of me, like part of what I like. So when you try to do what you like, I don't think it's going to be boring at all or hard at all. And when you get demotivated, just let's just do a new project, right? That's how I take it. It's going to be fun. Don't get like so much into like, okay, it's a code, math, algorithm, and so on. That's not the way. I mean, just make it fun. Just make it like a fun learning, and I'm sure it's awesome. Like your data is going to speak with you. You feel like someone, giving you all the information in a secret way. So it's a fun, uh, you know, uh, domain or field, I would say. So what are the websites for beginners? So I'm not like 100%. uh, I typically like take I typically get list of areas that I want to focus. For example, in data analysis, I want to learn pandas, right? So I Google, and I learn from different blogs, posts, online courses. So there is no like a typical like starting point that at least I had, but I can curate and send something if that will be useful. Is it necessary to learn enough theory to become theory? I mean, if you want to learn, it's important that you know the math behind the algorithm. I'm repeating this again and again because it's important that that you are able to infer what your system is saying. It's not just using the Python API and giving your data and just getting done with it. It's about understanding what the model is trying to convey for you, right? Yeah, I'm trying to find the article, but for some reason I'm not able to, but I'll forward it. Yeah. So where do you learn data science? For me, it's more like an online learning, and of course, I had my master's uh, courses. I had three. I took like 3 to 4 courses in data science, but I learned a lot more by doing projects by myself than sitting, than just sitting through the book, right? I learned by projects, and I learned by talking with people, networking, and uh, just being there in the community. Yes, I will forward this article for sure. And so free projects, you can use the UCI. You can just make a note of it. For some reason, I'm not able to type in. Okay, I think I can. So UCI repository Kaggle. I'm not sure if there is any other. So you can type for open source dataset and make sure the dataset that you're using has a proper license. It may look simple now, but if you're trying to use dataset without a proper license, then it's again going to backfire in your projects. So make sure you understand the license term of the dataset before using them in your project. So community, I mean, I went to meetups. I'm not sure because of COVID. I know things are pretty down, so it's all online now. When like before, I guess roughly like 4.5 years, I used to go with a lot of meetups. I tried to stay on LinkedIn and do projects and invite people, create groups, and do projects together, right? So I I don't, and also, this cheat sheet or this API, you will anyway understand the syntax. What is, no one is going to ask syntax, or no one is going to ask you how to use this package and so on, right? They want to understand whether you know the algorithm, whether you know the math behind algorithm, whether you can understand how the algorithm works. So that's the basics. It's not about whether we can know, whether we know to write correct syntax. Of course, there are cheat sheets, there are examples, there is Stack Overflow if you have any question. Yes, of course, like side hustle being a full stack developer, I'm not sure how much time you will have. But if you're really passionate about the field, I think spending like few hours a week, I know it's going to be slow compared to who's doing full time, learning here. But of course, yeah. AI is a part of the field. AI is the outer layer, and data science, machine learning, deep learning are like, a small bubble into the bigger bubble. So of course, we need to know that. Yes, there are like some. If you go to h2o.ai, and we have AutoML concept where you can just give your data, give your parameters, and it's going to build a model by itself. It's going to choose hyperparameters by itself. That, yes, of course, there is automation that's coming up in this data science field. It's going to, now there are systems that can build a model by itself, kind of.